I'm going to do a post real quick to let people know that we're live
Okay.
and let people come, and then we'll get started. We got a couple of minutes, so we'll let people
Yep.
join. Do you have any idea? So is it like when you do this at conferences, is it like 45-minute presentation roughly, would
Yeah.
you say?
Typically, yeah.
Okay, cool.
Usually when I do the webinars, it hits right at an hour because there's not a lot of questions. But like the
Oh, okay.
last one we did, we had one guy who attends all of our things. I think I don't know, he's our biggest fan. He asked 5 minutes of questions, so it was, you know,
That's cool.
yep. It was a good
Yeah,
thing.
so
Yep.
so hopefully we'll leave a little time. If there's any questions, we'll see. Let's see. Oh, I didn't know that was there. All the tech. Yeah. This is one of those things I think we just keep in my mind, if I just keep doing it, then at some point, we'll circle back around and have
Yeah.
you on again and type of deal. But but probably weird because I'm looking at myself, looking over like because of the delay, looking at my
You
other
got a little,
computer.
yeah.
Yeah, it's like a little creepy. All right, let's see. Patience is not one of my stronger suits. I'm
It's
like,
okay.
I want to get started. Like, we'll
Yep.
wait. We'll give it
Yep.
another minute and we'll
Give
start
it a
on
minute.
time.
Yep.
But at least we're gonna start on time today. We
That's right.
started, man. We were late a couple weeks ago. We had
And
all
that
if
people
there
may not stick around if you're not there. They might be gone. So
I
yeah.
yeah if there was a technical difficulty to be had, we had it. But
Yep.
this has been pretty smooth today. I got 11 o'clock, Jamie.
Yep.
I'm rolling. I'm
12 for
rolling.
me.
Welcome everybody. This is the second presentation in our Stormwater Live webinar series. The goal is to bring the conference presentations that you can't make it out to you here live on LinkedIn. And so I'd like to introduce Jamie McCutchen with Rymar Waterworks, and he is going to give a presentation today on skimmer basin design. And with that, welcome, Jamie. Thanks for taking the time, and it's all yours. Take it away.
All right. Great. Thanks, Ty. Appreciate the invite to be here, um, and opportunity to go through kind of what we do. So, again, my name's Jamie McCutchen. I am the founder of Rymar Waterworks. Today, we're going to talk about skimmer basin design, not only for during construction, but also post-construction. So, a little bit about me. I'm a professional engineer. Graduated Clemson in '92 in engineering. Owned my own company, CCAD Engineering, for about 20 years. Sold it about 6 years ago. Invented the Marlee Float Skimmer back in 2013 when South Carolina adopted requirements for surface dewatering or floating outlets or skimmers, whatever you want to call them. And like I said, I'm a licensed engineer in South Carolina, North Carolina, and Georgia. So today we're going to talk about a introduction to skimmers for floating outlets. I know for this platform, got a variety of folks that may or may not be used to skimmers. We'll go through the basics of a skimmer basin design for during construction for sediment control. And then we're going to pivot and talk about using skimmers for post-construction. If you did that, how would you model it? We're going to use HydroFlow as an example. And then we're going to wrap up with using it for Rymar water quality filter. Sorry, text that. And a filtration-based design, which is a really new concept in water quality, and hopefully one that you find interesting. So, before skimmers, we used perforated risers. So typically they had a hole near the bottom of the pond, or maybe they had perforations in the riser. But the point is, you're trying to settle all of the sediment to get it to the bottom of the pond so it doesn't discharge. But then we were withdrawing water from the bottom of the pond where that sediment is highest. Skimmers came around. They've been around probably 20, maybe 25 years now, depending on location. And the idea is that it floats. It drains the pond from the top down, releases water from near the surface where the water's cleaner. It's not clean water by any means, but it is cleaner. And it gives more time for sediment to settle out and stay in the pond. The Marlee Float Skimmer, which is our product, is a little bit different from some other products. We don't take water directly off the surface. We take it from just below the surface. Main benefit there is any floating trash or debris, even if you had an oil spill during construction or diesel spill and it got in the pond, that doesn't get discharged through the skimmer. It actually stays in the basin. There are a variety of skimmers on the market. The Faircloth skimmer kind of got this started. Mr. Faircloth out of North Carolina invented this maybe 25 to 30 years ago, I think. It's really become one of the more common products. You have the Erosion Supply Company skimmer, IAS skimmer, and then obviously the Marlee Float, which looks a little different than the other guys. So there's three fundamentals on sediment basin design, just to keep this simple. Number one is basin volume. So the basin volume is going to be based on the area flowing to the basin. The requirements do differ from area to area. What we see in a lot of states is a standard of either 1,800 cubic feet or 3,600 cubic feet per acre flowing to the basin. And then some areas also require basins to have a permanent pool or sediment storage volume that is below the invert of the skimmer. The important thing here we really try to harp on is use the required volume, not the actual volume when you size your skimmer. The required volume is often much less than the actual volume of the pond, especially if that pond is going to be your permanent detention pond later. Number two is dewatering time. So sediment basins work by simply allowing time for sediment to settle to the bottom. So depending on your soil type and conditions, that may vary as far as what you need. What we see as kind of the general standard is 2 to 5 days or 48 to 120 hours. But again, this varies state to state and even sometimes within MS4s within the state. So once you've got those two, you want to determine your flow rate. So fundamental number three is determining the flow rate for the basin. So it's simply the basin volume divided by the dewatering time gives you that flow rate. Now, as you go back to dewatering time, typically it's a range. So typically that flow rate has a range as well. And so we do recommend for engineering consultants when they're establishing that flow rate and going through the review, establish that range. That way you're not trying to hit an exact time. Skimmers are they're not super complicated, and a couple hours one way or the other is probably not going to make a big impact on the amount of sediment being trapped. So we recommend using that range of time when you specify it. So I'm going to go through just a couple of state standards just to kind of give you an idea of how they do vary. So Texas is one state that we're now seeing coming on, where skimmers are just now starting to be required. The Texas, I forget what TCEQ stands for, anyway, the State Environmental Quality Agency Construction General Permit requires sediment basins for drainage areas of 10 acres or more, and they do require outlets that withdraw from the surface. So this is from the Construction General Permit. Again, must provide sufficient storage to include a calculated volume. They say you can either do a 2-year 24-hour storm and calculate that based on the rainfall for your area, or provide at least 3,600 cubic feet of storage per acre drained. And then most CGPs include language like this that say, unless infeasible, when discharging from sediment basins and impoundments, utilize outlet structures that withdraw water from the surface, i.e. skimmers. Examples of infeasible, really the only one we've really seen is frozen conditions. So if you're in a state or area that has significant freezing, skimmers may not be the best choice during that time. And what we recommend is use the skimmer most of the time and maybe have an alternate outlet like a perforated riser that you can cut on and off with a valve to address those frozen conditions. And typically they'll have guidance on sediment basins. So in Texas there's a ISWIM or ISWM technical manual. It goes into much more detail about all the key requirements for the sediment basins, and typically has some diagrams, charts in there to kind of show you what they want in that particular area. Another example is Alabama. Alabama gets a little more detailed than Texas. So in Alabama, they have 2 different handbooks for erosion control, sediment control, and stormwater management. Combined, they're the Blue Book, Volume 1 and 2. Volume 1 has more of the plans and design practices. Volume 2 talks about installation, maintenance, and inspection for those practices. So in the Blue Book for Alabama, they give details on sediment basin, go through the key components. They go into detail about skimmers in the Blue Book. They do specify a dewatering time of 48 to 120 hours for the basin to function properly. And then they've got a little chart that kind of tells you the other criteria. So they recommend maximum 10 acres. That's actually for sediment trap. The sediment basin can get a little bit bigger than that. Based on a 10-year 24-hour storm event for your emergency spillway. And again, 3,600 cubic feet per acre of drainage area and dewatering time of 2 to 5 days. So just, it has other requirements in there too. I'm not going to go into those in detail, but it does spell it out for you as the design engineer what you need to do. One thing to point out, Alabama DOT does have an approved list of skimmers that they allow, and our skimmer is on that list. So if you are in Alabama, good to go to use us there. And then this is kind of a quick chart just to give a summary and show how some states differ. In this case, I just picked Texas, North Carolina, and Alabama to use as examples. Texas, again, 2-year 24-hour storm or 3,600 cubic feet per acre. North Carolina calls it out as 1,800 cubic feet per acre of disturbed area, so not total area. So they do recommend you try to divert undisturbed area around the basin. And then Alabama is also that 2-year 24-hour storm or 3,600 cubic feet per acre. Some areas specify a surface area for the basin. Texas does not. North Carolina and Alabama use this formula for 325 square feet per CFS of the 10-year storm. They typically require the principal spillway to be their 2-year or 10-year design. That principal spillway is going to be your skimmer, and typically if you have a riser structure in there, the top of the riser would be included in that. And then you typically would have an emergency spillway for larger storms. That's going to vary from the 25-year, 10-year, or some cases 100-year storm. And then where skimmers are required, it also varies. Texas, they look at big sites. They're 10 plus acres. North Carolina, anything 1 acre or larger, they want it. And Alabama says when necessary. So if you can't meet your trapping efficiency requirements with other means, then you need a sediment basin. And then the last one is dewatering time. Again, the 2 to 5 days is kind of the most common standard we see. Texas says 36 to 72 hours. So one of the big things about skimmers that we like to educate folks on is that skimmers have all long been assumed to be a constant head, constant flow dewatering device, which does make sense because they float and have the same head, pretty much constantly in the basin. However, testing has shown that's not necessarily the case. And so this chart is a chart that it comes from a study done by TRI Environmental for Alabama. The flow rates here go from 1 foot of depth to 4 feet, and they looked at 3 different 3-inch skimmers. And they don't tell us the brands they have here, but let's just say it's 3 different types of 3-inch skimmers. So what you'll see is down at 1 foot, 2 of the skimmers are pretty close. They're at 37 GPM. The other one is at 70, so nearly double that flow rate. As they go up, all 3 skimmers have an increase in flow rate, roughly 25% increase in flow from 1 foot to 4 feet. And again, 2 of them are pretty close, a little above or below 50 GPM, and the other one's about at 90. So the main point here is if you just say 3-inch skimmer and you don't give more information, you may or may not get what you really intended. You may get one, if you intended to have the 90, you may get one that flows half. If you intended to have the 50, you may get one that flows double. So important to specify flow rate when you're specifying the skimmers for your basin. We offer several tools on our website. They're pretty easy to download, but this is our basin design tool. So it lets you plug in your date, project name, engineering company, basin description. If you need any other information, you can put it in. So maybe it's like a phase 1 basin, and then you're going to convert it for phase 2 is differently. One thing we do is we have a check here for the required dewatering volume. So you're going to look at that area to the basin, whatever acreage that is, times the cubic feet per acre required for that area. So in this case, I'm using 1,800 cubic feet per acre. It's 7.5 acres, so our required volume is 13,500 cubic feet. Now over here is where you're going to plug in your basin, and so this tool does factor in that curve and the flow rates. So first thing you're going to do is specify that range of time. So again, we've got 48 to 120 hours, so 2 to 5 days. Pond depth is going to be the depth required to achieve that required dewatering volume. So if your detention pond is going to be your sediment basin is going to be your detention pond later, you don't want to say it's 8 feet here because that's going to calculate the pond volume to be much larger than required. So you want to use a depth that's required to achieve the required dewatering volume, then put in the top length and width and bottom length and width. Now I realize there are very few, if any, square or rectangular basins out there. So use your engineering judgment, tweak those numbers so that the calculated pond volume here is, we try to say, within 5%. Again, you're shooting for a 2 to 5 day range. You don't necessarily need to go back here and go 120.23 feet to try to get this thing to hit exactly that required. And when you do that, this tool will calculate for all of our skimmers with each orifice configuration what the flow is. And down at the bottom there's a skimmer report page tab. So you click on it and it's going to take you to this nice neat 8.5 by 11. The top side of this is going to give you all your input information. It's going to tell you the minimum flow rate based on the maximum time and the maximum flow rate based on the minimum time. So here's your flow rate range again that you're creating. It's got this check, so highlights for the reviewer. Hey, yes, we based our calculated pond volume is just slightly more than our required volume. And then because it is our tool, it's going to tell you which the drawdown time for every one of our skimmers, and based on your range that you specified as acceptable, which skimmers are acceptable. We typically recommend that you shoot for that 2.5 to 3 day drain time, depending on your site. If you've got really coarse soils, they're going to settle out quickly. Maybe you want to lean more towards the 2 day. If it's really a lot of silts and clays and be suspended, maybe you go to 3, a little more. But in this case, you've got a variety, 5 different skimmer orifice combinations that would meet that spec. We also have some basin details on our site. We have 4 different details for this. So we have details that have a riser structure. So this would be more of a multi-use basin that's going to be converted to your pond later. We have versions with a wet, so they have a permanent pool here that's below the invert. And then we also have ones that are set up for temporary. So maybe it's just a barrel through the dam and a spillway, and it's going to come out as a temporary basin. We have sediment design criteria over here. So length to width ratios are common. As far as requirements, minimum volume, you specify that, surface area if it's required. And here's where you set your minimum and maximum dewatering time of, again, we've got 2 to 5 days. Down here at the bottom, we have a data block, and this would be for each specific basin. So you'd have a drainage area to it, disturbed area to it, the flow rate, again, your basin volume, the required and provided, basin surface area. Again, you want to make sure that your provided meets your required. The outlet invert, pipe barrel size, that'd be your pipe through your dam, emergency spillway elevation here, and then skimmer size, skimmer orifice diameter, skimmer manufacturer. Is an equal allowed, yes or no? Most of the time that's going to be yes, but there may be some certain circumstances where you say no. And then skimmer flow rate. Here again, you're establishing that minimum and maximum. Now, because skimmers are used in sediment basins, they're typically one of the first things to go in on a construction site. And so if your contractor's getting started and he's like, hey, I've got this skimmer left over from this previous job and I want to use it here on this basin, can I? Pretty quick to check whether that skimmer falls within the range of flow rate specified. So hopefully that's a shop drawing review and not a full scale, have to resubmit, go back through a permitting process, because you probably don't have time for that in most cases. And then we also provide details of our skimmer. So what we have here is just a typical detail. One thing to point out about ours is we have this orifice plate. So some skimmers come with a disc that you cut, and it cut it to within 1/10 of an inch or so to hit a precise flow rate. Our design is a little bit different. We provide standard orifice sizes. Each skimmer is going to have 4 or 5 different combinations, and then you just select which one of those standard sizes falls within the flow rate range required. One of the other common questions is the pipe between the outlet structure and the skimmer. How long should that be? We recommend 1.4 to 1.5 times the height of the outlet structure. That will allow the skimmer to float at essentially a 45-degree angle when it gets up to the max height of the outlet. So easy for the flexible coupling to bend there and maintain that. You typically don't want the skimmer floating up at a 90-degree angle. Things start to get kind of wonky when that happens. So that 45 degrees is a good guideline. Many of you probably have seen skimmers in basins. This is one I like to point out. Contractor, I think, did a pretty good job here. We've got tracked in on the side slopes, so obviously they haven't seeded or grassed yet, but it looks like they're probably getting ready to do that. They've got their coir fabric baffles in, so that's great. One thing I like to point out here is the stone pad. Ideally, we would like to see this depressed. This obviously looks to be a dry basin. It has a minimum amount of storage below the invert, but it's going to be hard to get it dry because the skimmer is going to be sitting up 6 or 8 inches. And so the details typically call for that, and contractors sometimes don't do it, but we'd love to see that pad depressed a little bit to help drain as much water as we can out of the basin. Now here's one of the worst installs we've ever seen. This came from an inspector, sent it to us, and they were laughing, but there's no flexible coupling here. I'm not even sure exactly how that's attached. Obviously the pipe's way too short, nowhere near 1.5 times the height of the structure. If you look close, the outlet on this side, this valve's open, but most of the water is bypassing anyway. So we have seen some poor installs. We've seen 1 or 2 that have been installed upside down. They actually have a sticker that says this side up, but anyway, things happen. Again, this pipe's obviously way too short, and so this is not going to float very well. I guess the good news is it's going to drain the pond for the most part because it can't float up. And then do like to point out, skimmers are not maintenance free. Like most things in stormwater, some maintenance is required. This is one on a project site we did engineering on many years ago, but it had a vegetation growing out of the skimmer. And so if you see actually vegetation coming up out of the skimmer itself, there's probably a problem. In this case, there was a pretty big root ball in there, and it was really, the pond was staying full because water couldn't get out. So that's the basics on skimmers for construction. Now we're going to kind of pivot over and talk about permanent use of skimmers. Typically I do a little poll at this time. Oops, I actually still have it left. So just tell yourself, have you ever considered using skimmers for permanent use? So most people have not, although we're now starting to see a few people that have. So why would you do that? So this is our typical dry detention basin schematic. Okay, so typically construction in site stabilized, the skimmer is going to get removed. We're going to put a low flow orifice. We're going to install it at the bottom of the pond, and it's going to be sized most likely to release a first flush volume or whatever that low flow event is that you're required to handle. Typically you're going to have some sort of guard or filter here. Now keep in mind that for water quality in ponds, typically what we're trying to achieve is hold water in the pond long enough to let whatever sediment or pollutants settle to the bottom of the pond. And so again, we're settling them out, but then we're pulling that flow from the bottom where that pollutant concentration or sediment concentration is the highest. Skimmers on the other hand take water from the surface. So these basins again rely upon natural settling of sediment particles. So you're going to get some, the forebay is going to take some out, and then as they travel from the inlet to the outlet, you're going to see continually kind of drop down to the bottom of the pond. So if we release that water from near the surface, it's cleaner, and so we're going to let cleaner water out of the pond and give more time for the mud to settle. So this has been become a standard in construction, and just kind of makes common sense to let's consider using that same standard post-construction for a lot of the same reasons it works so well during construction. So one example of this, we did a pilot project. This has been our kind of playground for the last 10 years, just to show how skimmers can help with maintenance. This does not really focus on the water quality, although I know it does increase water quality, but from a maintenance standpoint. So this was a pond that was received a notice of violation, and it had not been maintained in probably 20 years. So you can see on this right picture, some of these pictures, it literally had timber. There were 6 and 8 inch trees growing in this pond. So the contractor got it cleaned out, but it was holding water, and we couldn't really figure out why. So we ended up installing, redesigning the pond and installing a skimmer. I'm going to skip over this picture. So if you look at this last photo, you can see the skimmer outlet here. You can see where the old orifices were. So we actually closed in these old orifices, put in some new orifices. What we found was there a 2-inch outlet 6 feet below the now bottom of the basin. So it had accumulated that much muck and debris and sediment over the many years of not being maintained. And instead of cleaning the pond out, which was going to be extremely expensive, this was a rare pond that actually had excess volume in it. So we redesigned the pond and we changed the outlet structure. And instead of going back with a 2-inch orifice, we got the county to approve putting in a skimmer. This was the first time that a skimmer was allowed for permanent use in this particular area, and they required us to monitor it for the first 12 months to make sure it worked properly. So we did that, and results were very good. And then about a year later, the then owner was deciding, hey, we're going to keep this pond maintained. So his landscapers were out there. They cut all the vegetation. Now this pond, it's about 3/4 of an acre. Side slopes are about 1.5 to 1. So they had cut everything, let it all fall to the bottom, and had a big thunderstorm show up, dumped 5 inches of rain in probably 4 to 5 hours. And so all the junk, debris, everything had been cut was pushed down to the outlet. But you see the skimmer sitting here. So, imagine if this was a 2-inch orifice plugged in there, and it got, would have surely gotten clogged by that debris. Instead, the skimmer was able to drain it down. This kind of gives you a better feel. This riser is about 8 feet tall total. So, if a 2-inch orifice down here got clogged and water was sitting up at this level, you're talking about a pretty dangerous situation to try to get in there and unclog it. And don't forget, this pond was originally 6 feet deeper. So the inside of this riser goes another 6 feet into the ground. So getting up to the top of it and climbing down in would be a real challenge as well. So if you're going to consider using skimmers for post-construction, we have to know how to model them in our software. HydroFlow is probably the most common hydrology modeling software, at least that's what we tend to see. And now that it's built into Autodesk, most engineers seem to have that. So this is a sample site that was done several years ago. It was done in an area that requires quantity control during construction. So pretty good example of pre and post rates with the skimmer. So this site was about 5.5 acres. 3.4 were being undisturbed, but they were still flowing to our outlet, to our pond. About 2.25 acres is being disturbed, going to a small sediment basin, and then it's discharging across this little side road, and there's a catch basin on the other side of the road that we're discharging to. So, just from a liability standpoint, we didn't want to increase the flow going across the road, and so we do want to have detention in our basin. So in HydroFlow, we set up our pre-development first. So we did 5.5 acres. It was a wooded site, curve number 59, time of concentration about 18.5 minutes. In this area, we used a type 2 storm event. Post-development, the 3.4 acres is undisturbed, basically the same criteria. The disturbed area, 2.25 acres, we used a curve number of 86. That's for basically disturbed earth, bare earth condition with a time of concentration of 7 minutes. What you're going to do when you do HydroFlow, this is one of the important pieces, is you need to enter storage at each contour to include data points so you can enter the skimmer flows. So you're going to basically create stages here that will allow you to enter the flow for the skimmer at each stage when you do your outlet structure. So in this case, we started at 0, and then 0.1, 0.3, and 0.5, and then every half foot up to 4 feet. Now again, this is our example. If you want to do every foot and you feel like that's going to generate your flow rate curves sufficiently, up to the engineer on how to do that. Because on the details, we provide you with the flow rate at 0.1, 0.3, 0.5, and then every half a foot up to 4 feet. It was 4 feet because the test tank was 4 feet deep, so that was the max they could go. And then you're going to build your outlet structure. So you're going to put in your barrel. So in this case, we had an 18-inch barrel going out of the pond. Bottom of the pond, invert elevation is 958. Small pond, but complicated structure. So we had a 6-inch orifice, 1.75 feet above the bottom of the pond. Had a riser structure that was 3.6 feet tall. And we had a rectangular weir 1 foot wide at 3 feet above the bottom of the pond. And then to build in our skimmer flow, we use the user-defined column here. So again, you manually enter the flow rate off the detail at the stage to create that user-defined flow rate curve for the skimmer. What you'll see, well, if your pond's over 4 feet deep, you've got a couple of different options. One, you can just maintain that flow rate at 4 feet. Number two, you can extrapolate it based on the last couple of points. Or if you really want to get complicated, you can go back to our design tool, plug in the actual depth of your pond, say 8 feet. We're going to then break that 8 feet into 20 different increments, and we're going to give you the flow rate at each increment. Now in this case, the sample here is showing our 2-inch skimmer with a 1/2 inch orifice, so the flow is very, very small, so it really doesn't change much over that. But larger skimmers, you're going to see a change, a more dramatic change, from that 4 foot to 8 foot level. And you can then plug in, these data points, entry points in your stage pond design. So when you look at the schematic with HydroFlow, this is typically, if you look at your outlet structure, normally you're going to see a low flow orifice down here at the bottom. In this case, you don't have that because that's that user defined. You've got that 6-inch orifice, a rectangular weir, and the top of the riser. But if you look at your stage discharge curve, obviously you've got flow starting at 0 and going out. So that's the skimmer flow, and then your 6-inch orifice, your weir, and your riser. And then if you can see this little green line, that represents the flow from the skimmer. So you just have a slight increase from 0 to 4 feet deep, and then the other orifices kick in. And then if you just do a double check, look at your flow table, your total outflow is going to be equal to your user-defined flow until you get up to where the other orifices kick in. So in this case, we hit 2 feet. We see now the 6-inch orifice is kicked in, and as you go up, so on. So that's it. So there's just a quick way to show how you would model that in HydroFlow. We know we're going pretty fast on these. So we have developed a training series we have on our website and our YouTube channel, which breaks down into 8 different parts. Number 6 The only one I haven't finished is on HydroCAD, how you would model in it. It's very similar to HydroFlow, but it'll go through, doing that. We also have a series on SedCAD. So SedCAD is a sedimentology software, so we show you how to model a skimmer in SedCAD as well. And we also have the volume-based and filtration-based, which we're going to talk about here coming up. So now we're going to go into kind of the next kind of a revolutionary idea on skimmers and water quality. And so this is a filtration-based model for water quality in a basin. So we've done research and development for a number of years. I think we're going on about 5 years now. This goes back to that pond that we showed as our example earlier. This is it, right after a rain event, skimmers in there, going to be draining it down, but you can see a pretty big rain, it pretty much filled it up. And so we've developed this filter system that's 2 stages. So this outer stage, this was our prototype. It was essentially a turbidity curtain, but it's hard to see in this picture, but it's got a screen in here, so it actually lets water flow through the area there. And then on the inside is a non-woven fabric that is actually set up in 2 layers, and it's got slits in it to create kind of a weaving action for water to go through it to create some contact time. This material absorbs hydrocarbons as well as helps with TSS, has some benefit for metals as well. And so we had this prototype in the basin for about 2 years to test and see if this would work. Now this was probably our 5th or 6th prototype. A lot of the early ones, just the filters weren't big enough to keep up with the flow rate of the skimmer. But you can see in this picture on the left, the turbidity in the main pond is noticeably higher than the turbidity at the skimmer. And then this is an actual picture of the outlet here. Pretty clean water. I wouldn't recommend drinking it, but relative to what's coming in, that's a pretty clean water coming out. So now what we did is we had third-party testing. We actually used TRI Environmental to do our testing for us. And this system of the skimmer with the filters was tested to ASTM standards and shown to meet over 90% TSS removal. So one thing to point out about our testing, again, TRI Environmental tested it. We tested 2 versions of our skimmer. So the ASTM standards require you test two versions, and the flow rate one has to be nearly double the other. So have a wider range of flow rates in it. ASTM C1746 is the standard. It's relatively new. It's a standard for sediment retention devices. And the tank was set up to minimize the effect of the pond by introducing sediment-laden water within 2 feet of our filter. So what we wanted to do is we didn't want to say, well, how much of our percentage is from the forebay, how much is travel distance, how much is whatever. We said, hey, what is this system, if we put in our sediment-laden water, and that gradation of sediment is specified in the ASTM standard, if we do that and we do it right at our skimmer or at our filter, and we let our skimmer pull the water through the filter, what kind of results do we get? The other thing is this filter is about 3 feet deep, so our test tank was about 4 feet deep, so water could come underneath the filters, but the idea is that gravity then does the work because there's not enough flow rate or force to pull that flow and sediment particles up to the skimmer to be discharged. So this, now we go back to that pond. Again, this kind of gives you a better feel for how the size of that pond and the side slopes we talked about before. And we've now got our commercial version installed there, and we are monitoring it with a time-lapse camera. The outside here is just a Mirify 402 fabric, so a polyethylene fabric. It acts as a screen. And then the inside again is our non-woven. It's a material called Adsorbit, which again has properties to absorb hydrocarbons, help with TSS, metals, and hopefully eventually we'll do some testing to see if it helps with other pollutants such as nitrogen and phosphorus. Currently we have only tested this for TSS. Adsorbit has a variety of other tests for pollutants of just the fabric itself, but not in this system. So I want to kind of talk about what are the benefits to filtration versus settlement when you're doing a pond. Okay, so first thing is the peak rate of discharge from your basin. If you're doing filter treatment, you can establish that filter treatment flow rate up to the first quantity storm event. So what I mean by that is, let's say in your area, the quantity control requirements are that you control your pre and post for your 2-year storm as the first storm. Well, if you can have a filter that can handle up to the flow rate for that 2-year storm, you can now treat up to that 2-year storm event. The other thing is the filter treats 100% of the runoff from the storms up to the peak rate of the filter. So why is this important? Traditional pond design that has a first flush volume is typically like a 1 inch, maybe 1.5 inch of volume over the site. And you size your orifice to let that volume out over a specified time, say 24 to 48 hours. But what happens when you have a 1/4 inch of rain or a 1/2 inch of rain over 8 hours? You're still washing off all the pollutants from the parking lots and other areas, but you're getting very little ponding in your ponds. And so therefore, because all of our ponds are typically requiring or relying on settlement to achieve water quality, you're getting very little treatment. And then the other thing is our filtration media can be customized to target specific pollutants of concern. Like I mentioned, we've already incorporated material that will absorb hydrocarbons. We see that as a pretty common concern. It may not be regulated, but everywhere is still a concern. And so we've already built that into our system. So now what are the benefits to using skimmers with filtration? So we could just do a filter. We could come up with some way to put a filter in the pond by itself, but then we're probably still going to be filtering the stuff at the bottom of the pond. So when we use a skimmer, well, one, we can size the skimmer to control the peak rate for that lower storm events. So depending on the size of the site, you may be able to select a skimmer that can be your quantity control for your 2-year storm. The skimmer is going to increase the filter efficiency by withdrawing from the surface where the water is cleaner. So as the skimmer filter combination is going to float up, you're now treating water that's cleaner than trying to treat the stuff that's at the bottom of the pond. And then finally, the skimmer is going to be fairly easy to access or pull to the side of the pond for maintenance and changing of filters. Obviously, maintenance is still going to be required. Not going to require a confined space entry or something to get in a vault to have to do for other types of filtration. But it's not a perfect system, so there are challenges for sure. So number one, obviously filters are prone to clog over time. They will require some maintenance, potentially periodic cleaning. We currently recommend changing the filter every 2 years. In our prototypes, we really didn't clean, except for just some very minimal maintenance during the first 2-year period. But we noticed it was still working, but we're starting to see some UV degradation after about 2 years. And so we decided it was time to change the filters at that time. Number two, the skimmer's got to be durable. And so earlier we showed a variety of skimmer types. A lot of those are PVC. And just PVC is not going to hold up as well in UV long term. Also, it's more susceptible to frozen, cracking or something in frozen conditions. So our skimmer is an HDPE product, and so we do recommend using a skimmer that's durable and lasts. Ideally, you want a 20-year product out there. And then finally, one of our biggest challenges is there are no established standards for basis of design and permitting when you combine a pond and a filter. There are some standards in many places for mechanical treatment devices or proprietary products. They'll rely on manufacturer recommendations, rely on third-party testing, go through different things, but it is not common to see those combined with a pond. Typically your ponds have standards and your devices have standards, but they don't necessarily go together. And so that's one of the things we're working through at a state level and MS4 level to make sure the MS4s are open to allowing the filter to be used and to not have to use that first flush release with it. So last thing here on the skimmer side, we're going to go through a comparison of a first flush volume, volume-based first flush release versus a filtration-based flow rate of filter pond design. And this is just going to focus on the water quality portion. We're not really going to focus on the quantity event except up to the 2-year storm. So we're going to have a sample site. Let's assume it's 5 acres. Let's assume it's a wooded site, so a curve number, say 55. And we're going to a commercial shopping center, say curve number 92. So first thing we're going to do is develop our pre-development flow rates. So based upon the 5-acre wooded site, it's going to be 48 minutes for a time of concentration. Flow rate is going to be 0.72 CFS for the 2-year storm, 3 CFS for the 10, 5.4, 10.7. But again, we're going to focus here on the 2-year storm event. Next thing we're going to do is look at our water quality volume and our post-development flow rates. So again, based upon that 5-acre commercial site, we're now going to assume a time of concentration of 10 minutes. What we want to do is we want to determine what is that water quality storm event that would generate a 1-inch volume. Okay, so that first flush volume is going to vary by state or MS4. 1 inch seems to be one of the more common standards, so I used it in this example. But if it's 1.5 inches, it's going to change that water quality storm event. So kind of trial and error in HydroFlow. I came up with a 1.73 inch 24-hour storm that would generate approximately 18,150 cubic feet of runoff volume. So run that through the program, come up with 7.2 CFS for our flow rate for the water quality event, 19.72 for the 2-year storm. So 19 CFS increase from pre to post in this example. So this is going to vary. I know a lot of engineers have their own customized proprietary way to do this, but this is a spreadsheet that we see that's fairly common. Determine what the orifice size would be for that first flush. So again, we've got our first flush volume here. We're 1 inch. We can use a dry pond. We wanted to release it over 24 hours. And so it's going to determine what that average flow rate is, and we're going to average out the head on that orifice. And so we come up with a 2.6 inch outlet to release this volume over 24 hours. Now, one thing to point out is one fallacy with this concept is this assumes that entire volume kind of poof, magically appears in the basin instantaneously. Obviously, that does not happen. There's a hydrograph of inflow into the basin that we see. It comes in slowly, typically has a peak, and then starts to drain out. So, we're not really going to use 18,000 cubic feet of volume for that water quality event, but that's typically what we see as the standard when we go to do this. So we run this through the model. In this case, instead of modeling a 2.6 inch orifice, because I'm not sure a contractor would get that right to put it in, no offense to contractors, we're just going to make it easy and call out a 3-inch low flow orifice. We'll have some sort of trash guard on it. Then we'll have a 3-inch orifice at the 113, so basically 3 feet above bottom of our pond, which correlates to the volume or elevation needed for a volume of 18,000 cubic feet in this hypothetical pond. And then we'll have an 8-inch orifice 2 feet above that. That's going to control our 10-year storm. And then our riser structure is going to be our 25, emergency spillway for the 100. And so again, 18,150 cubic feet is this volume that's required for water quality in our design. However, if we run this out, we look at our peak flow for a water quality storm going out is only 0.25 CFS, and we're only using 10,700, just under 10,700 cubic feet of volume for that water quality event. So it's hydrograph, water coming in, water going out. It wouldn't nearly use the full 3 feet of depth here or that full volume. And our 2-year storm, we've got it at 0.81. Now, if you remember, our pre was 0.72. And so depending on your area and your reviewer, are they going to allow a 0.1 CFS increase from pre to post? Maybe, maybe not. But our 10-year, 25-year, we're detaining. And then if you look at this, your pre versus your pond flows, again, water quality event, pre had almost nothing coming off. It's at 0.25, 0.81. So again, slight increase in the 2-year. 10-year, 25 are being detained, and 100 years being managed through the spillway. And the storage required is here, and we'll just reference that for later. So the alternate way to do this is going to be with the skimmer and then add the filter. And so what you want to do is first, let's look for a skimmer and see if we can find a skimmer that would manage our 2-year storm event. So in this case, again, we had a 0.72 CFS is our target for our 2-year. If we look at the options here, the 6-inch skimmer with a 6-inch orifice has a peak flow rate, and again, this is at a 4-foot depth of 0.78 CFS. So I'm saying that's a good one to to trial in the model here. So we also have details for the filters. So one thing to point out about the filters are sized so that they keep up with the flow rate of the skimmer. So the filter's never going to be your controlling factor. It's always going to be the skimmer, so you don't have to model the filter in here. Do pay attention to, we have an L1 and L2. L2 here, we don't want L2 to be greater than about 20 feet. Really, we keep it down to 16. Because what happens is you've got a pipe here. Typically, you don't want this more than 20 feet long. You have to start joining pipes together. It creates some challenges. And so as this skimmer rises in the basin to that 45-degree angle, this is going to be coming closer to your outlet structure. So typically, we don't want more than about 8 feet here to make sure we don't bump up against the outlet. Again, we pointed out before, the filters are about 3 feet deep. So they hang about 3 feet into the pond. And then you've got two different ones. You've got the outer one, that's the Mirify, and the inner one, that is the absorbent fabric. And so the table here is going to give you the lengths required for each. So do note that some of these get pretty long. Like for our 8-inch max, which has a flow rate of just under 2 CFS, that L1 on the outer is 46 feet. So you're going to have 23 feet in each direction here. So typically that amount of flow would be a pretty large pond, so probably no problem fitting that in. But if you're doing the design, you do need to check that. Make sure you got enough room in your pond to actually fit the filter. One thing to point out, the filter sizes are based on scaling the flow rates from our testing. So we looked at two things. We looked at one, let's assume all the flow goes through the filter itself. So there's a flow rate per square foot of material. So we maintain that. And then we said, okay, let's assume worst case, nothing goes through the filter and it all goes under. So what's the flow rate per linear foot for each one? And so we maintain both of those when we came up with our filter sizes. Then we also have pond details. One thing to point out, you may have noticed in our previous details on our sediment basins, we showed the skimmer parallel to your dam. That was just for ease of maintenance. You know, if you can tie a rope to it, a little easier to pull it over to the side. For the permanent version, we're showing it sticking out into the pond. Again, some of these filters get pretty large, and what we don't want to do is get, you know, a filter hung up on the side of the bank. So we want to have it kind of sitting, you know, not in the middle of the pond, but kind of out away from the bank. And then you've got all your data that you're going to need for your basin design here. So now let's run that through our model. And what we're going to see is that our water quality volume is going through the skimmer, through the filter. It's now going out at 0.7 CFS. Remember, before it was 0.25. Our 2-year storm is now 0.78, so slightly less than the other model, but still slightly over that 0.72. And the 10-year and 25 are being maintained. We're only using 7,600 cubic feet of volume. So we're taking advantage of the flow rate, and we're only using 7,600 cubic feet of this water quality volume that would be 18,000 cubic feet under the first flush model. And you'll see there's also no other outlet until you get up to the 8-inch. So our skimmer is now our low flow orifice and controlling our 2-year storm. And now if we compare this to the traditional design, so the pond with skimmer, here's the storage required for it versus the storage required for our traditional design. You can see these numbers are less, a little easier in percentage format. So 30% reduction in the water quality volume required using the filtration rate versus the volume-based rate, and 14 to 12% on the larger storm events. So in summary, you are now using the skimmer filter, you're treating those low flow storm events, because even the trickles have to go through the filter to get to the skimmer to get discharged. You're treating the higher flow events. We're treating up to a 2-year rainfall. So I think that's a 4.4, maybe 5-inch rainfall event in this area. So rather than treating just that 1.73-inch rainfall, you're treating all the way up to like a 4-inch or higher rainfall event. So much more of the annual rainfall is getting treated. And then you are doing so with a smaller pond. So Any of you consultants out there, if you have a developer that's like, oh no, I want a big pond, let me know. I've only had one so far. It was down in a coastal area and they needed the dirt. So they were digging a bigger pond because they need the dirt. But by far and large, we see anytime you can reduce the size of the pond, that's definitely something they want to do. And again, I would do a poll right now, but I can't do it on the LinkedIn side. But hopefully you just think to yourself, are you now more likely to consider skimmers for permanent use? I hope the answer is yes to that, and you will at least consider it as a tool in your toolbox. So real quick, I want to just talk about Rymar. This is our website. We're pretty proud of it. I think it's one of the better ones in the industry. I really thank Ty. I'm going to give him a plug. He really helps us with that. So thank you, Ty, for keeping us up to date and keeping it there. Um, we have our resources and training. We have our on-demand webinar as well as our other tools on here. And then we have our engineers pack. So if you download this, it's one zip file. It's got basically everything you need for construction, skimmer details, and post-construction. Our skimmer, just a couple things about it. It's an HTP product. It's very UV resistant. It holds up extremely well. It's got a debris guard on it, so it keeps it floating out. And it continues to work at least in mild frozen conditions. Now you're up in, say, Cleveland, Ohio, and you get a foot of ice, you're just going to stop up, okay? So, or if you're in northern Indiana, we've got to consider some options for frozen conditions. But most of the country, it'll take in water from about 4 to 6 inches below the surface, so it's going to continue to work in most conditions. I mentioned our orifice plate before, just a little quick video to show how that works. So just a piece of EPDM rubber goes in there. We've got this little metal nub here that is helps make sure the orifice gets centered, or the orifice plate gets centered over the orifice. Like I said, every one of our skimmers comes with 3 to 5 different flow rate options, and all have been third-party tested. Oops, missed one. Hopefully that will work. So one thing about our skimmer, when it originally came out back in 2013, it was a little different design. We changed that up back in 2020, and so it always stays level. This is Aaron. He's our shop manager. Got in the pond here or in our test tank and just said, hey, let's make sure this thing always floats correctly. We do have custom floats for our 6, 8 inch. Actually, now our 3 and 4 inch use something similar. Make it easier to carry in the field. And then we do have 6 different versions. So our 2 inch goes down to ½ inch orifice, which is a trickle. We have 2 different 8 inch. Our standard 8 inch uses a 6 inch pipe, and our 8 inch with 8 inch pipe uses 8 inch pipe, and again has a flow rate almost 2 CFS, so about double most other 8 inch skimmers in the market. And then wrapping up here, one thing I just want to quickly mention, we're now working with a company called Digital Sightbox. They're based in South Carolina, have been in South Carolina for coming up on a year now, starting to see it expand in other states. This simple sign with a QR code is the alternative to the traditional job site box. So we've all seen these. If you've been on a construction site, you've seen wet plans, wet inspections, missing inspections, not up-to-date plans, or just no box at all, just got knocked into something or disappeared, right? Or my favorite is the occasional wasp nest when you open up one of these and have to take a run away. Digital Sightbox is a digital solution. It is a simple website, so there's no software or apps to download. Puts all your projects in one place. It includes a rainfall log. There are ways to secure certain folders if you need to keep it private. Most of it is designed to replace that job box so it's publicly available. It also has messaging and time stamping, so if you need to see who looked at something, it'll tell you who logged in, who looked at what. You can upload basically any type of document, and it's, I think it's about 5 gigs of storage per project, so should easily hold most of your information. It is free for municipal users, so if you've got any folks with MS4s listening in or watching this, you go in and create your free account. What that does is any project that's set up in your area will automatically be added to your account. So if you're an inspector for the local city, county, and you're like, hey, we just had a big rain, wonder how my site's held up, you don't have to ride to everyone, open the box, check the inspection report, see what's on. You can, from your office, pull every site up, check the latest inspection, see which sites you need to prioritize for your visits. Cost is very competitive. So essentially, it's $150 per site if you're less than 50 sites. If you go over 50, it's $100 a site. Over 100, $75 a site. Even at $150 a site, that's far less than what you're going to spend on just getting the plans printed. If you do go in and sign up, and you heard it here, we ask in the sales rep code, please type in Rymar. That will let them know that we got this out to you. I will admit we get a little compensation from that, and we do appreciate it. But we're trying to help them get the word out, and so we do ask that you include that as your code. So we want to thank you, Ty. Really appreciate you letting us come on.
Yep.
For those of you that listen in and need a PDH certificate, email us. I believe that's safe to still provide over there. We'll probably send you a little quiz to make sure you actually listened. If you listened, you'll pass. But if you didn't, you may have trouble with it. But email that to info@Rymar Waterworks, and love to have you contact us with any questions.
Yeah, and spoiler alert: this presentation is also on YouTube, so that if they really want that PDH and they've forgotten,
That's right.
then they can get some. They can go do an open book test. But hey, we have got if we can just circle back, we did have one question.
Okay.
Sahil asked, "I'm curious how it holds up in winter freezing conditions. I can understand its work function much, but is it durable tested to survive a freeze thaw cycle?" He's up in Canada.
Yeah, so we've sold a handful of these in Canada. I know my geography on Canada is not the best, but I know in Quebec we've sold a few that have stayed in. They're used permanently, so they're used at a site that is helping with water quality issues there, and so they have held up very well, from what I understand. Ohio, we've sold a lot there. I've got photos from the Cleveland area where they've had a freeze, have pictures of people walking out on the ice with the skimmer in the ice, and when it thaws, it's working fine. So I will say I have not heard of any damage from freezing. I can't promise it's never happened because I don't hear everything, but I'll say we've never been made aware of any issue with freeze thaw.
Gotcha. Sahil, thank you for your question. We do have a couple more minutes left before we get off, Jamie. And when we do go off live, don't hang up right away. But
Okay.
is there any major your top? How about like your top FAQ, like top two questions that always get asked? Do you want to? You've knocked out. I mean, this is a great presentation. I mean, you cover a lot of stuff, but I mean, I don't know if you've got.
So I'll tell you the top one. The top one is, why is it the Marlee Float? Where in the world did that come from? Okay.
Fair.
And so I'll tell you, as mentioned before, I'm from South Carolina. South Carolina adopted regulations back in 2013. In 2012, the state, our program DHEC, was going around doing educational seminars about what the new CGP requirements were going to be. One of those was surface dewatering, i.e. skimmers. December 2012, our daughter had a bad night. She was 11. She wanted to sleep with my wife and I, which was the first time in probably 3 or 4 years. She's tiny, but she's a little ruder. So I got elbows, knees hitting me in the back all night because she's just moving all around, and so couldn't sleep. For whatever reason, thought of the idea for a skimmer. Lay there in bed. Actually got up and sketched it out. Aaron, who you saw in the tank, he and I worked on it for the next 6-9 months. Finally got something. We're like, hey, we think we can actually sell this. Well, what are we going to call it? Well, let's call it the Marlee Float in honor of my daughter Marlee, who inspired the idea. So that's why it's the Marlee. And for those that wanted to, Rymar, we used to be called SW Products. We had a name change back a few years ago. Our son's Ryan, and he was a little jealous that he wasn't getting any credit either, and he does help with the company. So we're now Rymar for Ryan and Marlee. So it's definitely a family business, and everybody's involved. So
That's awesome. Hey, it's a great presentation. I mean, if you're, I don't know how you would have any, I don't think you get a ton of questions when you do this presentation because you cover, I mean, that is in an hour. That was a lot of detail in an hour. So
we try to pack it in, and that's why we've got the training series now too, because I know a lot of this is, hey, I'm trying to find this. I don't want to listen to the whole thing to find this one nugget.
Right.
So we've broken it down now in segments for what you're looking for. So I'm an engineer. I've sat through how many lunch and learns that are just pure sales. And yeah, great to know about the product, but I really want to learn something. And so as an engineer, I'd really make an effort to try to, we want people that listen to us to learn something and come away with, hey, that was actually worthwhile. It wasn't just a sales presentation. This guy knows what he's talking about and provided some value. So
100%. Thank you so much for doing this. I appreciate your time.
absolutely. Glad to have it.
All right. All right, everybody. Join us a couple weeks. In a couple weeks, we'll have Joe Moore with Siltworm and ECS coming on, and he'll be talking about sustainable BMPs and sustainable SWIP design. So until then, we'll see everybody later. Thanks.
Thank you.